Hello everyone and welcome back to another video of competitive programming. Today we'll be taking a look at another British Informatics Olympiad question. Today we'll be taking a look at a very nice question taken from the 2016 paper. Okay, so let's have a quick read of the question first. Feel free to pause the video and just have a read. I've highlighted the parts which I think are quite important. And yeah. And this is finally the final part of the question. Okay, so now I'll just jump onto the whiteboard and quickly explain the solution which we will be implementing for this particular question. So pretty much what the question states is we need to be modeling some sort of migration model, okay? And yeah, this is just a small section, but if we have a certain starting situation, let's just say something like this, okay? So we need to model exactly how this particular migration will continue out throughout a period of time. So maybe let's just make this starting with 3 instead of 4. And now let's say that we choose to add a particular value to this particular cell, okay? So what that would basically create is instead of that 3 will now become a 4. I'll just do this in a different color so it becomes clearer. So that 3 will now become a 4. Then what will happen as soon as there's a 4 is that particular 4 will become a 0, and then 1 will get added to all of its neighbors. So these were all 3s, and that was a 2, and now they'll become 4, 4, 4, then 3. Okay? And now, pretty much what the solution to this is that now that all of these values are 4, and then we just need to apply whatever we did right there for this particular cell again. So if we just apply this recursively, updating the values of all 3 of these as well as their neighbors, then that will pretty much model the migration for one particular term. And now the beauty of implementing this particular code is that we know that at the end of one particular migration, all of the cells have to be less than 4, okay? Which means at the start of another migration, if we add a particular value to a cell, then we know that any changes which are caused to adjacent cells, making them greater than or equal to 4, must have been due to that particular cell. So then if we just apply this recursively, and then apply the algorithm to these 3, and then those, for each of them, we apply it to its particular neighbors which have been affected due to the migration, then we know that we would have covered all possible cells which have values changed because of the migration. And now, one final part of the question is that we need to model the migration not just for a 5x5 board, as the question quite clearly states, but we need to model it for a larger board. So in this case, I've chosen to model it for a 100 by 100 board. I mean, like 100 by 100 is still very small, and it's just so we don't have any errors of it being out of bounds and potentially affecting the middle board again. Okay, so that's pretty much the solution. Now let's have a quick look at the actual code which I've used for this question. So I've created this game class, and if you notice, I use the same framework throughout. I have game class, and then move, play, and then output, and also translate sometimes. I just find it to be much easier creating in a class and all of these modules. And move normally refers to one particular move. Translate translates between different forms, normally what the question gives and what the computer understands. And then play puts it all together, and output clearly outputs it. So I would recommend that you do something similar for these question 2s, since it will help you considerably, from my experience at least. Okay, so we initialize this grid array. It's a 100 and 101 by 101 array. Everything is 0 initially, since there's no people initially. And then these start, sequence, and moves. So start is the starting element. Sequence is the sequence. So let's say 5, 6. So that would basically mean we add 5 and then we add 6 to our previously changed cell, and moves is the number of moves basically. So now let's just walk through this move function. So what the move function does is this carries out the migration, if you like, for one particular cell. So it takes in the coordinates of that particular cell and converts them into its R and C values, so row and column values. And then if that particular value is greater than or equal to 4, only then will we bother to do something, right? If it's not greater than or equal to 4, if it's 3 or less, then we just return nothing, because we don't need to change the value of that cell or any neighbors if that particular cell is only 3. So if it's greater than 4, what we do is we subtract off 4. Now this is very important. Excuse me. In the first time when I coded this, I initially set this equal to 0, and I was encountering a bug with some of the large cases, and I wasn't entirely sure why. And the reason why is because let's say let's just go back to the whiteboard where I can probably explain this a bit better. Let's say we have the situation where this is what we have here, and then this is one particular section. Now, if we I guess it makes probably a bit more sense if this is 3, this is also 3, and then this is also 3. So let's say that this is a cell which is added to. So then that means that this particular value will then change to a 4. So let me just write that on in a different color, 4. And then what will happen is that all of these neighbors, they will also change. They will also get incremented. So then this will be 0, since one neighbor has gone to each of its cells. And then all of these will be 4. This one will be 3. And now what will happen is that both of these would simultaneously add 1 to this neighbor. And then this neighbor would have its value of 5, basically, after both of these are done. This means that if it's 5, then after 1 is exited from each of the 4, then that will leave 1 instead of, because one particular person is leaving through each of the 4 adjacent squares. So we do 5 minus 4 instead of setting that equal to 0, since that would cause some errors in the future. Okay, so that's just one small caveat which you might miss out, like I did. And then what we do is we have this overcrowded array. This overcrowded basically stores all of the adjacent neighbors, which are also overcrowded. And then what we will be doing subsequently with those is that we will be performing this move function on them as well. Okay, and then this is exactly what I was saying earlier. We apply this recursive function, and then that sorts out everything basically. So what we do is we have this adjacent. So adjacent is the 4 adjacent values. So one of them has the row value -1, row value +1, column value -1, column value +1. And then for neighbor in adjacent, so for each of these 4 neighbors, we set xy equal to neighbor. So xy is just the row column values. And then we increment this particular xy. And then if it's greater than or equal to 4, then we append it to the overcrowded, i.e. it needs to be sorted out inside the next function call of move. Okay, so that's the move function. Now over here we basically have the translate function. So what this does is, if you recall back in the question, they basically I asked us to right over here. They said that we will use the following method to add people to the grid. So the bottom right corner, we'll place people within a 5 by 5 section of the landscape. Top row contains 1 to 5, next row contains 5 to 10. This should contain 6 to 10, actually, it's a typo. So that the bottom right corner is 25, okay? So we need some way to translate this 1 to 5, 6 to 10, etc. back into our Cartesian coordinate system. So then what this basically means is that it means that if we consider our 5 by 5 grid, since the dimensions of the total grid are 101 by 101, the top left corner will basically have the value 48, 48, since remember indexing starts from 0. And then the way we determine the what value to add to the row and column value is we do num1 minus 1 divided by 5. So what this does is this is the quotient when divided by 5, and num1 minus num minus 1 mod 5. So this is the remainder when divided by 5. Okay, So if you're not sure why exactly this works, maybe just try it out with a few examples. So for example, let's say 12. 12 minus 1 is 11. 11 divided by 5 gives 2. That means it's the second row. And then 12 minus 1 mod 5 gives 1, which means it's the basically the first column. And now this means that the second row, which basically means the third, because we start from 0, and first means second, so it means position 2, 3, taking 0, 0 as the top left. And then that will basically be what we return from this translate function. And now this play function just puts everything together. So we start off, next is basically the next element to which we will be appending things to. We start off that value with whatever the start is. So the start's the original one. And then for num in sequence, if the moves are 0, so pretty much what we're doing is we're decrementing the counter of moves. And then once that's reached 0, we know that we've exhausted all the moves which need to be done, so then we return. Now, if next is greater than 25, that basically means that the position is greater than 25, so we just subtract off 25. And then chords is equal to self.translate next. So what this does is this just gets the coordinates of the next particular value. So we translate the next. And then what we do is self.grid plus equal 1. So this takes the x and y values of the coordinates, then it adds 1, and then we finally perform this move function on the coordinates. And then remember, this is recursive, so this will deal with all overcrowded cells. Then we subtract off 1 for moves, and then we increment next by num, where num is the next element in the sequence. Then we just repeat this again and again for each value. Okay, and now output, all we have to do is, for I in range 48 to 53, we print off that particular row. Okay, and now we just take in these as input, sequence as input as well, and then we just perform the play function. Okay, so that's pretty much it for this particular code. I really hope you enjoyed watching this video. Hopefully you learned something new as well of how we perform this questions code. And if you did, please be sure to leave a like and subscribe. Also, it's worth mentioning that if you would like to check out the code and play around with it, the link is attached to my GitHub down in the description below. So feel free to check that one out. And thank you very much for watching. I hope to see you in another video next time. Bye.